Hello and welcome to another Ginger Mathematician video. So today we're going to go through all things A-level maths paper 1 or AS level maths paper 1 on sequences and series, and we are going to be using this particular part of the formula sheet. So remember, in the A-level exams you do get certain formulae, and for this video in particular it's very important to know these particular formulae. Just one point to make here, I also use the other version here, so Sn equals a brackets r to the power of n minus 1 over r minus 1. You may have been taught that in class as well, so it's important to realise you have that alternative. Right, let's get started. So we have question 7 here, so slightly more on the difficult side. And we've got a little bit of worded question here. So when we have this, again, just take your time, look through the question, and then make sure we are answering everything for the 3 marks. So a tool for putting fence posts into the ground is called a post rammer. Not particularly important, but again, give us some context. The distance is in millimetres, that's important, that the post sinks into the ground on each impact of the post rammer follows a geometric progression. So whenever I'm doing a sequence and series or progression question, I want to identify, is it geometric, so multiplying each time, or arithmetic, which is then adding or subtracting. So this is going to be multiplying, so keep that in mind. And the first 3 impacts cause the post to sink into the ground by 50, 40 and 32 millimetres. So essentially we have a sequence here that goes 50, 40 and 32. And we need to verify that the 9th impact is the first in which the post sinks less than 10 millimetres into the ground. So as soon as I see a sequence and I see geometric, I need to be thinking, right, what do I need to work out the nth term? And in this case, we need the first term for a geometric progression and what's called the common ratio. Then we can apply our nth term formula to that. So notice here we actually have this formula on the formula sheet, so we're going to come back to that in a moment. But we need to find this first term a and common ratio r. Now the first term is really straightforward, we're already told this, so a is equal to 50. To work out the common ratio, all we need to do here is take, for example, the second term, so 40 divided by the first term. Or we could take the third term and divide that by the second term. So it's the term afterwards divided by the term before. And if we pop that into our calculator or simplify the fraction, we will then get 0.8. So now we know what a is, the first term, and the common ratio, so what we're multiplying by each time, in this case times 0.8, we can then write down the nth term. Now all I'm going to do is going to copy down this formula, so ar to the power of n minus 1. Wherever I see an A, I'm going to put a 50. Wherever I see an R, I'm going to put a 0.8. So this is the formula that represents to work out anything in the particular sequence. Now it wants us to think about the 9th impact. So I want to work out this nth term when n is equal to 9. So when n is equal to 9, we pop this into the formula. So we have 50, open bracket, 0.8. to the power of 9 minus 1. And I'll just pop that into my calculator. So make sure you've got your calculator handy here. And we should get 8.38 ... And this is in millimetres. And certainly this is less than 10 millimetres into the ground. However, we're not finished here because we need to check when n is equal to 8, so the term before, and just ensure that that is above 10, so therefore it is the first in which it goes less than 10 millimetres. So to get the full marks on this question, it's a little bit sneaky. We also need to check when n is 8. So very similar calculation, just 8 rather than 9. If I pop that into my calculator, I then get 10.485 ... millimetres, and therefore 9th impact, I'm just going to write this as a sentence, is the first below 10 millimetres. So notice here, again, I'm taking this question very seriously and making sure I'm getting all the marks by checking the n is 8 and making sure that is not below the 10 millimetres. If it was for whatever reason, I would then check my working and make sure, do I have the correct first term? Do I have the correct ratio as well? Now on to the next two parts of the question, which are much more standard. And the first thing, find to the nearest millimetre. So notice the rounding that we have to do here. The total depth of the post after 20 impacts. As soon as I see total in any question, I am thinking the sum formula. Now remember from before, we're looking at geometric here, not arithmetic. So I go back to my formula and go, okay, I want to use the geometric series formula. So I'm going to be using this one. Notice how I've broken that down to find the correct formula. So if I write this formula down, just don't have to do this in the exam, but just so I've got it here. Again, we can use either formula, absolutely fine. So a brackets 1 minus r to the power of n over 1 minus r. And now we just substitute in our values. So a, the first term, was equal to 50 here. The common ratio was equal to 0.8. And then we just pop this in. So we're looking for S20. So notice n here is equal to 20 because we have 20 impacts. So then we pop in 50, open brackets, 1 minus 0.8 to the power of n. However, we now know n, so we pop in 20. There we are. And then we have over 1 minus 0.8. And this is now just a calculator exercise. Make sure when you're typing this in, you're very, very careful, making sure you put the brackets in the right place. Notice there is a decimal point here. And if you put this in correctly, you'll then get the answer of 247.117 ... However, this is where we want to pick up that second mark to the nearest millimetre. Read that question. So we just want to round this then to 247 millimetres to nearest millimetre. So very important, read the question. This will change sometimes, so you do need to make sure you're putting down the precise answer for those 2 marks. Now question C, again, is also a classic. I see a particular word or phrase and it triggers something in my mind here. So here we have find the greatest, that's important, total depth in the ground, which could theoretically be achieved. So as soon as I see a phrase like greatest, or I see a phrase like theoretically could be achieved, I'm already thinking to myself the sum to infinity formula. That's the first thing that goes into my head here. If I go back, we have the sum to infinity formula here, just right over here, which is equal to a over 1 minus r. And notice the magnitude or the modulus of r needs to be less than 1. Notice in this question, we have r is 0.8, so that does fit the condition. Therefore, we are allowed to use that formula. So I'm going to copy it across. So S infinity is equal to a over 1 minus r. And notice again, we've got a is equal to 50. Again, double check these things in the exam. R is equal to 0.8. So we pop it into our formula. So we have 50 over 1 minus 0.8. And then that's equal to 250 millimeters, which is our correct answer. Notice in the context of the question, so we go back to what we worked out. After 20 impacts, we had 247 millimeters. So the answer of 250 millimeters makes a lot of conceptual sense. It should be a little bit more than 247, but not that much more, as we're already converging quite quickly to the theoretical greatest total depth. Again, you can have a look through the answers here and you can see where we picked up the method mark. I've taken this approach for part A. Again, you could use logarithms. That is absolutely fine as well. And then kind of solve the equation at this point and then look at an inequality. That is absolutely fine as well. But just be aware that this approach here that I took, which I think is a bit more common sense approach, is also perfectly fine as well. Okay, on to a very different style of question. It is earlier in the paper, so on the surface it should be more easy to do, but there's less structure in this kind of question. And this can come up, and I'm going to show you how I think about this question. So we have the first, second, and third terms of an arithmetic progression. I see that key phrase, so we're going to be adding or minusing in our particular progression that we've got here. And we have a, 2a, and a squared, where a is a positive constant. That's more important than we think. as we go through the question, and we want to find the sum of the first 50 terms of the progression. Okay, so the first thing I'm going to do is just write down the progression a, 2a, and a squared. Now notice this is arithmetic, which means we're either adding or subtracting. And whenever we're talking about arithmetic progressions, when you talk about the first term, well, that's just equal to a anyway, that's kind of convenient. But we do need to work out this common difference here. Now, some students, they see a question like this and they think, there are no numbers, there's no numbers. How can I even work something out without any numbers? However, let's just follow the idea for a common difference. To work out the common difference, all you need to do here is very similar to what we did with geometric, which is you can just take the second term and minus the first term. Or we can take the third term and minus the second term. It's the difference between here and here and here and here. Now we can form two expressions to do this. So d is equal to, well, 2a minus a, so second term minus first term, or it's equal to third term, a squared, minus 2a. And because both of these things are equal to the common difference, these two things must be equal to each other. Therefore, a squared minus 2a is equal to 2a minus a. Still feels like at this point we're not going to get a number out of this, but keep the faith, we're going to go through this now. So first of all, we can just simplify the right hand side. 2a minus a is just a. Then we're going to bring everything to the left hand side, because notice here, let's do this in a different color, we have a quadratic, yeah? So even though this is not a quadratics video, if you want to check out my quadratics video, of course you can always go to the playlist and find quadratics there. But notice we're using other knowledge from the course, so we are using quadratics here and that knowledge as well. So what we need to do then is go minus a from both sides. That gives us a squared minus 3a is equal to 0. And this is actually a very straightforward quadratic here to solve. We have a common factor of a, so we take a out. Then we work backwards. So what do we multiply a by to get a squared? A. What do we multiply a by to get minus 3a? Minus 3. And if two things multiply to give you 0, I'm sure you've heard this a lot. So either a is equal to 0, so the first part is equal to 0, or the bracket is equal to 0, and therefore a is equal to 3. Now notice we have two possible answers, but back to something I underlined already, a is a positive constant, therefore 0 is not possible, therefore a is equal to 3. Now let's write this question out a little bit differently. Now we know a is equal to 3, the first term is 3, the second term 2a, 2 times 3 is 6, then 3 squared is equal to 9. So notice I'm always double checking as I go through the question here. Do we have an arithmetic progression? Are we adding 3 each time? Yes, we are. So we do have the correct progression. Now we want to find the sum of the first 50 terms. So we're going to use the S50 formula. Notice this is arithmetic. So we're going to be using this formula over here for an arithmetic series, and specifically this one on the right hand side. So let's pop this in. So we have n over 2, so n is 50 here, so 50 over 2, 2 lots of the first term, so 2 lots of 3, plus n minus 1, again n minus 1, 50 minus 1 is 49, times the common difference, well we are adding 3 each time. At this point, you can either do this without a calculator, you can break this down, or pop it straight in. I tend to do a mixture of both here. So 50 divided by 2 is 25, 3 times 2 is 6. 49 times 3, again, no need to do this mentally. Again, in exam pressure, you don't want to be relying on that. And now if we pop the rest of this into the calculator, we get our final answer of 3,825 to get us all 5 marks on this particular question. Okay, you could have a look through the mark scheme, say where I pick things up. So notice we've got this part here. I can put A is 3 or D is 3, so that's interesting. I didn't explicitly put D is equal to 3, so possibly at this stage I would write D is equal to 3. just to make sure we're getting that third mark there. So I didn't do this. Then we use the S50 formula and then pop this in to get 3,825. Okay, and on to question 9. So a little bit more of a tough question. If you found this so useful to you so far, then please do like and subscribe. That helps the channel go a long way. And if you want more of this A-level content, also looking at stats of paper 5, then certainly it's something that's in mind. So the first term of a geometric progression, I'm underlining this every single time I see this, is 216, and the fourth term is equal to 64. And from this, we need to find this, and we've seen this before in the video, sum to infinity. Now let's just go through some sort of fundamentals here. If I have a geometric progression, then we can write this as our first term A, then we have A times R, which is AR, then we can have A times R times R, then we can have A times R times R times R. So that you can write any general geometric progression in this way. This simplifies down to AR. Remember, R times R is just R squared, and R times R is just R cubed. So the first 4 terms of any geometric progression can be written in this way. We're told that this fourth one here is equal to 64, and we're told the very first term here is equal to 216. So if I take the fourth term here, so this AR cubed, this is equal to 64. However, we already know what A is. We know A is equal to 216. Therefore, we can say 216 R cubed, so replace the R with the 216, is equal to 64. And this is now just a straightforward equation to solve here. So we're going to divide both sides by 216. Remember, we want to get that R on its own as quickly as possible. This cancels, giving us R cubed. And again, fractions are the way to go here. 64 over 216. So at this point, once we've got that, then all we need to do is then just work that down to our final answer. So all I'm going to do here is I'm going to cube root both top and bottom. If I cube root top and bottom, I'm going to get my answer of 4 over 6. But again, we can simplify that again down to 2/3. Again, so all we have to do, if I just show you on the calculator here, is we just take the fraction or cube root of our fraction 64. Well, calculator can just do this for you, and see we get immediately to the answer of 2/3. Now we know what this common ratio is, and we know the first term. We can now use this formula that we've seen before, this formula here. So this S infinity is equal to A over 1 minus R. So now I'm just going to copy that formula down. So S infinity is equal to A over 1 minus R. Our first term here is 216 divided by 1 minus 2/3. Again, let the calculator do the mental maths for you. That's what it's there for. So 216 over 1 minus 2 over 3. We pop this in and we get our final answer of 648. Please use that calculator wisely when you're going through. Sometimes you'll need to simplify, but in that case, if you've got something like this, just put it into the calculator, let it do its stuff. Again, you can always double check with some mental maths as well. That's perfectly fine. On to question B, and this is where it gets a bit tricky. Again, as soon as you see a 6-mark question towards the end of the paper, you need to think about this quite carefully. So let's read this through. The second term of a geometric progression is equal to the second term of an arithmetic progression. Now remember how we wrote out a general geometric progression, A, AR, AR squared, AR cubed, and so on. We can do exactly the same for an arithmetic progression because we're just adding or subtracting each time. So our first term would be A, the second term is just A plus whatever the difference is. The third term would be A plus 2 lots of the difference, 2D, A plus 3D, and so on. So this here, this is useful for your notes, so make sure if you need to go through this, write this down. This is geometric here, multiplying each time, whereas here this is arithmetic, also known as linear sometimes. So very useful notes to have. So if I take the instructions from the question, the second term of the geometric progression. So when they say the, it is what we've just been doing. So r is equal to 2/3, a is equal to 216. So what this is saying here, the second term of the geometric progression, so a times r. So with this one that we have, it's 216 multiplied by 2/3. If you're wondering where those numbers come from, they're coming from the previous part of the question. And this is equal to the second term of the arithmetic progression. So this a plus d. So these two things are equal to each other. We do a very similar process for the next one. So the third term of the geometric progression is equal to the fifth term of the same arithmetic progression. So the arithmetic progression is the same top and bottom here. So the third term is going to be ar squared here. So we have 216 2/3 squared. Remember, using part A here. And then the fifth term of the same arithmetic progression, well, we've got the first term, second term, third term, fourth term. So our next term would be a plus 4 lots of d. So we pop that in like so. Now we're just going to do some work out on our calculator. So if we do 216 times 2/3, again, we're just going to use the calculator to do this for us. And what do we get if we pop this in? We get 144. So we can say, because this is equal to 144, a plus d is equal to 144. If we work out what this is in my next box I'm drawing, so we're just going to hop this over, getting 96. So then we can say that a plus 4d is equal to 96. So I just worked out what this was that I put the arrow to. Notice we've got a very conveniently simultaneous equations. Again, an important skill on the iGCSE and also A-level course. So what I'm going to do is going to do it by elimination. I've set this up very nicely. I'm going to minus one equation from the other. So a minus a is 0. 4d minus d is just equal to 3d. And 96 minus 144. If we pop this in, that gives us minus 48. And therefore, we'll d on its own, so we divide by 3 on both sides. This cancels, giving us d minus 48 divided by 3. Again, you can use a calculator if you so wish, but we then get minus 16. Before we can work out the last part of the question here, we still need to work out what the first term is. Now we can use any of the equations we've seen so far. I think in this case I'm going to be using this one. So we're going to sub in 1. So we've got a, wherever I see a d I can now put minus 16. This is a very straightforward equation, and therefore adding 16 on both sides we get a is equal to 160. Now you're probably thinking at this point, oh, that's a lot of work to get the 6 marks. But we're not finished yet, so we have the sum of the first 21 terms to find of the arithmetic progression. This is why we spent so much effort working out the first term and the common difference. So let me create a new slide so we have a little bit more room to work out the last part. So just to remind ourselves, we have a is equal to 160, d is equal to minus 16. And we want to work out the first 21 terms. So our n here is going to be 21. And because arithmetic, go right back to the start here. There we are. We're going to be using this formula over here. So we're going to be using the arithmetic one, not the geometric. So if we pop this in, let's pop the numbers in, see what happens. So we get 21 over 2, 2 lots of a, so 2 lots of 160. Plus m minus 1, so 1 less than 21, that's 20 times minus 16. Again, you could simplify this down if you so wished, or you can just cancel. So you've got 10.5 here, got 320. This is helpful. So 20 times minus 16, and if we work that out, that's minus 320. So that means we're going to get 10.5 times 0, and anything times 0 is equal to 0. So So after all that effort for those 6 marks, the answer is just 0. That's what it was at the end. Okay, you can have a look through the mark scheme there. You can see where I picked up these marks. Again, quite useful just to write these down. Again, both required, so it's important to be very, very clear how you got to these answers. Okay, and over to a more unstructured question like we've already seen. Again, you can see question 2, question 7, question 9 does vary on the paper here. So the 13th term of the arithmetic progression is equal to 12. The sum of the first 30 terms is equal to minus 15. And from that, somehow, we need to work out the sum of the first 50 terms of the progression. So first of all is arithmetic. So if we wrote out a standard arithmetic progression, we'd have a plus d, a plus 2d, dot, dot, dot. Now notice here that a plus 1d is the second term, a plus 2d is the third term. Therefore, if we want the 13th term, this number here is always one more than this term. Notice this. So we're actually looking for a plus 12d here. Notice the pattern here. If I did the 4th term, this would be a plus 3d. So notice the pattern. This is why the 13th term is equal to a plus 12d. So we can write this down. So a plus 12d, my first bit of information, is equal to 12. Now this is a bit more complicated here. The sum of the first 30 terms is minus 15. So S30, which we can start using the formula at this point. So we have 30 over 2, 2 lots of A. Now n minus 1, 1 less than 30 is 29, multiplied by D. At the moment we don't know what A or D are, but that's fine. And this calculation is equal to minus 15. Okay, so we can simplify this down slightly. 30 divided by 2 is 15. 2a plus 29d is equal to minus 15. And because we've got a 15 outside the bracket, this is a great opportunity just to divide the whole thing through by 15. So if we divide by 15 on both sides, always look for these opportunities to simplify if you can. This cancels, leaving us with the bracket. So 2a plus 29d, and minus 15 divided by 15 is equal to minus 1. Okay, now if I wrote this equation underneath and tried the elimination method, notice it doesn't quite work at this point because we have a 2a and an a. So before I write this down, you see it's fine to make mistakes. You see, this is why I show you these typical mistakes and then how to think about it afterwards. What I can do here, to be quite sneaky, I can times by 2 on both sides. Perfectly fine as long as you do the same thing to both sides. That then gives us 2 lots of A plus 12 times 2, 24d is equal to 12 times 2, which is 24. So I'm going to pop that underneath. Now notice I can use the elimination method directly, which is very, very helpful, rather than trying a substitution approach or something else. So now I can just minus one equation from the other. 2a minus 2a cancels. 29d minus 24d is 5d. Minus 1, careful here, negative numbers. Minus 1 minus 24 is minus 25. And it's always a good sign because now we're going to divide by 5 on both sides because our common difference here is a whole number. If this is happening, then you're probably on the right track. Again, there could be a 2.5, this is true, but usually these differences are generally whole numbers on this paper. So now we know D is equal to 5. Don't forget here, we want to work out A as well. So I'm going to substitute into 1 here. Into 1. That means I'm going to copy out this equation here. Wherever I see a D, I'm going to put a minus 5. And this is just now a straightforward equation to solve. So we have A minus 60 equals 12. Therefore, A is equal to 72. So just like before, we spent a lot of effort here working out the first term and the common difference of this particular progression. Again, still not finished for the 5 marks. We still need to find the sum of the first 50 terms of the progression. So I think I need a little bit of room here to finish this question off. So let's write down the critical information here. So we have, first of all, A is equal to 72, D is equal to -5, and we want to work out S50. Okay, so N is equal to 50. So if we pop this in, S50 this is equal to 50 over 2, 2 lots of A, so 2 lots of 72, plus N minus 1, so 1 less than 50, 49, multiplied by -5. And this is a case where we can just put this in the calculator, a bit of simplifying. So we get 25 here, 72 times 2, that's 144. That's not going to be a plus, that's definitely going to be a minus. 49 times -5, so minus 245. Again, we can just pop this straight in the calculator at this point, or a little bit earlier. Both are absolutely fine. And we get our final answer here, minus 2,525. And that then gives us all 5 marks for this particular question. Right, so you can have a look at the mark scheme here. Again, you can see all the different stages I've gone through here. Again, writing out this, using that simultaneously to work out this part, and then feeding it through to get these 5 marks. I do find out of the topics on this particular paper one, it's one of the easier topics to really get a good understanding of quite quickly. So I really do encourage you to go through this video quite carefully and make sure you're getting all these marks on these fairly straightforward questions here. Okay, and on to question 2 here. So the second and third terms, let's underline that nice and carefully, for geometric progression. So remember, we are multiplying each time here are 10 and 8 respectively, and we need to find the sum to infinity. So again, we can think of this as our first term. Now the second term of a geometric, remember, is just A times R, and then the third one, as we've seen before, is A times R, or AR squared. So we're told here the second term, just to translate the question here, is equal to 10. That's what it means by respectively. And then the third term, that's going to be equal to 8. So we have here that AR squared is equal to 8, whereas AR is equal to 10. And we're going to see a technique we haven't quite seen yet, but still using this idea of elimination. Now, when we're doing arithmetic progressions, we took one equation away from the other. We can use a similar technique for geometric progressions. So what I'm going to do is divide one from the other. So if we go through this, A divided by A is just equal to 1. R squared divided by R to the power of 1, that's just R. So think of this as R squared divided by R to the power of 1. Just using our index laws here. And then 8 divided by 10, well, that's just 8 over 10. Or we can write this as a decimal or fraction as 0.8. So now we know what R is equal to. We can now substitute that back in. So we're going to substitute into the easiest equation here. So substitute into 1. So wherever I see, this is a 1, wherever I see an R here, I'm going to put a 0.8. So we get A times 0.8 is equal to 10. Therefore, A is equal to 10 divided by 0.8. Again, if you don't like that mental maths, we can always pop this into the calculator. That's going to give you 12.5. So now we know this A and D, or A and R in this case, we can now use the sum to infinity formula. Again, we've seen this a few times now in the video. This is equal to A over 1 minus R. We pop in A, that's going to be 12.5. We know R from previous part is 0.8, so we have 1 minus 0.8. Again, we just pop this into our calculator. Again, being nice and careful, making no typing errors, and then we get our final answer of 62.5 as our sum to infinity. Again, if you use fractions, that is also perfectly fine. So you can see the answer here. So again, you can have it in lots of different ways. My calculator gave it as straight away as 125 over 2. That's also fine for all 4 marks. On to our next question, slightly different to what we've seen so far. So the first, second and third terms of an arithmetic progression, important word, so we're adding or minusing each time, are k, 6k and k plus 6. And we need to find the value of the constant k. Now we know what the first term is, that's just equal to k, but we don't know what the common difference is. But we can use a technique that we've already seen in this video. So the common difference is just, say, the second term, which in this case is 6k, minus the first term, which is just k. Or we can say it's the third term minus the second term. So k plus 6, the third term, minus the second term. And notice now we actually have an equation to solve, because these two things must be equal to each other. So 6k minus k, that's just 5k. Again, we can just write this out in full. So if we do a little bit of simplification here, k minus 6k, or almost 1k minus 6k is minus 5k. Again, this is just a straightforward equation here. We're going to add 5k on both sides, so we get 10k is equal to 6, and therefore k is equal to 6 over 10, also known as 0.6. So with this kind of question, again, we're using that same idea of if you want to work out the common difference, second term minus first term or third term minus second term will do the job here. Now we need to find the sum of the first 30 terms of the progression. Now before I do a question like this, in this great exam technique, we now know k is equal to 0.6. So if I write out this progression, we have 0.6, 6 times 0.6 for the second term is 3.6, and then k plus 6, well 0.6 plus 6 is 6.6. So before I do anything in this question, I'm going to check this is arithmetic before I try and get into these 3 marks. Notice it is, because we're just adding 3 each time. So we've confirmed it is arithmetic, and we haven't made a mistake in the previous question. One of the worst things you can do on an A-level paper is you've got that answer, but not double check that it actually does do what it says. It should be arithmetic. Because if you notice an error here, you can go back and then try and find the right answer. Now we want to find S30. Again, using that formula that we've seen before. So n over 2, so 30 over 2, 2 lots of the first term, so 2 lots of 0.6, plus 1 less than n, so that's going to be 29, times a common difference, which we just worked out. That's equal to 3 here. Again, we can simplify this down, so we get 15, 1.2 plus 29 times 3 is 87. And if we pop the rest of this into our calculator, we can let it do the hard work for us. And I'm getting my final answer. Whole number is always a good sign, 1,323. And that gives me then all 3 marks for this part of the question. Again, you can have a look through the mark scheme and make sure you're happy with what I've done so far. Hopefully by this part of the video, you are getting more comfortable with all the different techniques you need to have on this A-level Maths paper 1. Now we have a slightly different style question. So even though it's question 3, it's slightly strange in its construction, and this can throw some students off. So we have an arithmetic progression. So again, adding and minusing here. First term of 4, so a is equal to 4, and the common difference is just d for the moment. And the sum of the first n terms of the progression is equal to 5,863. Okay, that's kind of strange. I mean, to show this random thing seems to exist. Now, the first thing I do with a question like this, I just write out the sum of the first n terms. So essentially, Sn, we're just going to write the formula from right back at the start of this video. So we have n over 2, 2 lots of a. However, we know what a is here. We know a is equal to 4. So we have 2 lots of 4. Now, we don't know what n is, so n minus 1. And we don't know what d is, so we leave it as d. And this whole thing is equal to 5,863. Now, this is a really important algebra technique. I see what I have here, and I want to make it look like this. So essentially, I want to make this n minus 1d the subject, this whole thing the subject. Now, the first thing I can do here is just do a little bit of simplification. So 4 times 2 is 8. I'm going to definitely leave the n-1d alone because that's what we want at the end. Okay, well, we can certainly multiply both sides by 2 to get rid of this horrible fraction. So that seems a thing to do here. Again, fractions generally want to simplify here. So we can cancel this out, leaving us with n 8 plus n-1d is equal to, now 5,863 times 2 is 11,726. As soon as I see this in the question, I must be on the right track here. I'm not too far away. Now let's get rid of this n. So the opposite of timesing by n is dividing by n. You see I'm slowly building towards what we need to show. This cancels, leaving us with 8 plus n-1d. And we're dividing by n, so we can just write this as a fraction, getting very close to what we need. And you can probably see at this point, all we need to do then is just minus 8 from both sides, and then we get exactly what we are looking for. So n-1d is equal to 11,726 over n minus 8. Bit mean for 1 mark, to be quite honest. There's quite a bit of algebra to do there, but okay, it's, again, as I said, slightly strange question. This is why I've included it in the video. Now, given that the nth term is 139, find the values of n and d, giving d as a fraction. Not much structure here to work with, but let's see what we're given first of all. We're told the nth term is equal to 139. Now, if I go right back to the start here, so we've got through a lot of work today. The nth term for an arithmetic geometric series, you see this equation here, is a plus n minus 1d. So what I'm going to write down is that a plus n minus 1d, the nth term, it says that on the formula sheet, is equal to 139. Now we actually know what the first term is, don't forget that. We know a is equal to 4. So I'm going to pop in 4. And all I'm going to do is just subtract 4 here. And you're thinking maybe why at this point, but that's fine. n minus 1d, and that's equal to 135. The reason is, we spent a lot of time in the previous question working out what n minus 1d was. n minus 1d was equal to this expression here. So all I'm going to do is wherever I see an n minus 1d, I'm going to replace it with what we know from part A. So all I'm going to do is replace that with the right hand side. So 11,726 over n minus 8 is equal to 135. This is actually an equation that I can solve. Slightly unconventional, but certainly I can solve it. I can add 8 on both sides. That gives me then 11,726 over n is equal to 135 plus 8 is 143. Again, there's a couple of different ways you can do this at this point. You've probably seen it from trig, but you can kind of flip these. But let's just do it in the kind of standard way here. I'm going to multiply by n. Again, if you can go straight to the answer, it's fine. So I'll get 11,726 is equal to 143n, and then I divide through by 143. Yeah, if you do sine, cosine, and tangent, you see this idea a ton. So this cancels. So we get n is equal to 11,726 over 143. And this is where we hope this is a whole number. That's always a very good sign. And it is. Therefore, n is equal to 82. Okay, so we've done the first part. We've worked out what n is here. Now we need to work out what d is. Well, I'm just going to use what we did in part A. We now know that n minus 1d is equal to this thing here. So that's quite useful to know. Or we can actually just use this here actually instead. This is much simpler. So when n is equal to 82, so I'm going to use this formula here. So that means then that 81d, one less than that, is equal to 135. Therefore, d is equal to 135 over 81. Now you can be really lazy at this point, just use your calculator to see if you can simplify it. And you can simplify this down to 5/3. Be interesting if they actually, do they give you the mark for this, or do you have to simplify it? That'd be interesting, but as standard practice, you should be simplifying your fractions. Okay, so here are the answers. So you can get the D is 5/3, which is the very final bit that we did here. Again, making sure that we've gone through that working nice and carefully. And if you want to get your integration up to scratch, and making sure that you know how to do the integration questions, which are some of the more difficult on this paper 1, then do check out the video right in front of you, because I do exactly the same thing as you've seen here, but for integration, making sure you're ready for the paper 1.